you guys need to npm install after you pull well, a branch.
In the web setup?
Yeah, webpack setup. Why don't we no, there's some error. Let me just comment it out. This.
You gonna push it?
Yeah, okay, I'll push it. Make sure it runs. No?
Hey.
Hey.
Hi-oh.
Did we like tell the people there if anybody comes there to come?
Yeah, I did.
Yeah.
Okay.
Isn't this the entire class though?
Well,
Yeah, basically.
Ron Blair. Oh,
there.
the other guy.
Leon is.
I think they're cashed out, those two. They're TKO. They're like, we're done. We're not gonna use it.
Yeah.
Later.
She waited right for like React Native and then just like peace out.
Yeah, she's like, this is too much.
I mean, she hates doing in-class stuff. I guess.
I replace. Oh crap.
So I pushed the fix. So you guys should be able to run this.
What are we doing today?
So doing performance.
Oh,
Perfect. That is. It's gonna be alright there. You wanna? So
that's fine.
NPM install.
npm install and then npm run dev.
thanks.
Run dev. So again, we are in perf branch of the webpack setup repo that we've been working on. Perf branch. So if you go over to the did you pull the latest?
Yeah, I'm on Earth. I'll just do it again.
Yeah, I'll see. Sure. Oh yeah, this okay.
That's common.
Yeah,
Where is
should work now.
webpack setup still?
Yep.
Alright.
Where?
So yeah, so if you go to the perf folder here. So let me just recap what React is doing under the hood. So if you define state, this is a declarative web program. You declare a state, and then React renders that state into the virtual DOM, and then the virtual DOM gets projected to the actual DOM by React render engine. So whenever you change your state, you call a set state, or you use Redux Flux, you call the dispatcher action to change your state. React always try to re-render your DOM. So actually, you're gonna compare the actual DOM and then try to find the difference and then try to re-render. So this where React is performing badly as opposed compared to Angular and other front-end frameworks is when you have a huge list of stuff. So here I created just a fake 2,000 list of 2,000 items and put it in my to-do list. So here is that. You'll see that if you navigate away and then go back to this route, you'll see that it takes almost 2 seconds to appear. It's pretty bad performance. And then and if I edit, say add to do, I enter, takes almost 2 seconds. And you see that from React, actually we have a performance helper. So if you import perf from React add-ons -perf, you can use that library to time your start and stop time, and then print it out. I'll go over the print out way. So if you pull up the console, we'll see that the item I just added took about 810 milliseconds to and that's in wasted time. So what's wasted time? So you see, I added this item to my state, but all the other almost 2,000 items stay unchanged. So that means when I added that item, React has still to traverse through all that 2,000 items in order to make sure nothing else changes, and then renders that onto the screen. So that means the time that React takes to go through all the 2,000 items is roughly 810 milliseconds. And that's a lot of suffering in performance because we know nothing else changing. So here we can actually help React out by telling React that you don't need to go through all the 2,000 items. So how do you do that? The easy way to do is you go over in your to-do items and then use a built-in factory helper. It's called should component update. So this would be next prop, the next state as the argument. So you would return. So let's just see what we're trying to return. So in each item, we're returning this props.body. So somehow we are passing a body of a to-do item. So our fake to-do items are ID and the body. So we're just gonna see. So this should component update always return a true or false. So if it's true, then React will try to compare it, so go into this component and compare the props. If it's false, it's just gonna skip it altogether. Not gonna even bother checking anything. So we don't want to this to-do item to spend time checking if this props.body is not equal to next props.body. So if it doesn't change, then we don't want to waste time, trying to re-render that. Okay.
In the case of like a newsfeed,
Yeah.
you can always put false there, right? Because you don't want.
Yeah. You can always
False.
put false. You can if you think this item would never needs to be updated, you can just put false there. Yep. So So let's see how this helps. Let's see if it goes okay.
Where's the so that method call there?
Yeah. Wait.
I'll let you run it first.
Which method call?
So should component update. Where do you pass those params?
This is a built-in factory function. So this is like a component did mount, component did update.
I see.
Yeah, it comes within React. So it's just built in with the first argument as the next prop.
Mm-hmm.
Next props meaning the next props that's different from these props.
The props
So,
that are coming in now
that's coming in,
are different
yeah,
from
yeah.
what
Right.
already is.
Right.
Okay.
Okay. So once we have that, it refreshes. Okay. So once to do. So now it's pretty fast, snappy, and if I look at item, so it didn't even bother calculating the waste time because nothing's wasted. So all the 3,000 items, React didn't bother checking.
So you should always have this.
Not exactly though. Sometimes you may have items here that depends on the new item, for example. For example, in our to-do here, it's not gonna be like that because see, we have 1, 2, 3, 4, 5, 6.
And then it shifts
Yeah,
up.
it shifts, so it always gonna depend. So not necessary that you always gonna have this, but a lot of components.
What shifts up?
The index 1, 2, 3, 4, 5.
Need to be rearranged.
Yeah, it depends on whatever changes you need to add.
Yeah, well, yeah, there's a lot of instances. But yeah, it's true. A lot of components always gonna have this, and it's so common that you have a factory function, factory helper. For example, here, if you look at the React docs, they have this pure render mixing. So this is actually just a helper. You drop into your component, and it just automatically takes care of these 3 lines for you. So you just drop it in, and it's just gonna make sure this component would not spend any, time or energy, trying to re-render if this prop and next props are different. So that's one thing. Okay. So any questions on how you can speed up? So if your problem with performance is a lot of lists on your screen, a lot of items, for example, like eBay, Amazon, then an easy solution is to add in a shoe component update and then make sure you don't spend energy
Can you
rechecking
do
stuff.
that on the actual item so the actual thing that's being replicated many times?
Yeah, you mean you talking about this example?
Well, in any example, like a post,
Mhm.
you would put it in the post.
Yeah, you would put in post. Yeah, so if it's right, so this is very common. One way of checking.
So this dot body is what?
This dot pops up body is the body of the item. You know, here this is a to do item. So each single line is a to do item, and this item 5, item 6 is dot pops the body. Okay, so if you look at the to do list component, we call it to do item, and then passing body is body. Okay. So yeah, so this one's
This runs before the render?
yeah, this runs before the render, right?
So when an element is added, though, we're still going to have that wasted time, right?
An element is added,
Yeah. So like, could you add an element to the page?
like added
like,
to do
yeah,
here.
buy milk or something like that.
I don't know. No, we don't waste any time because we don't bother checking, you know.
Okay.
So this is why yeah. So let me just remind you what it was before. I mean, if we don't have this,
It'll just update the entire list.
yeah, you would just go into the entire stuff, and then by milk, you can let me just hit enter.
So it may not necessarily update, but it checks inside.
Right,
the
it has to check because
That's the default.
yeah, React
Binding to read stuff.
makes no assumption about your state.
What if all of them were called item?
Which one? Item?
What if all of the items,
Yeah.
instead of buying item 1, 2, 3, they were called item? Because you're checking the body, right?
Yeah, they're
If
checking
all of
the
them were called item, we still.
No, it's not about the different from the neighbors. It's just different from the next pop. So for all the other items, this pop is the same. Item 20 is always the same as the next pop because it's the same list. We just added one to the list, right? So we are not
compares the idea of one to-do item with the other.
Right.
The new to-do item that comes in, it's the same,
Right.
therefore it doesn't update.
right. It doesn't update, right? But it still has to check, and you spend so much time checking it, right? So okay, so we're back to here. This equality or inequality. I mean, looks right? We can just drop it in, and it's fine, right? But what if my body is something like yeah, content, and then we have a like strike through or stuff like that. Strike through false, and then what? Underline. Why am I crashing?
Just read immutable JS.
Yeah. Well, let me close this. Why am I confused? Underline. Yeah, something like that, right? True. Then this comparison is no longer that simple. Okay. So let me just take a brief detour and then talk about something very, very simple and maybe you guys don't know. So let me just go no, right? So no, if I have like say var x equals 12, var y is equal to 12, then x checking if x is equal to y is going to be true. But if I have say var car1 is equal to say color red, var car2 is equal to color red. What about this? Is car1 equal to car2?
No.
Yes or no?
No.
No? No? Everybody? Yes?
It's just gonna port down.
Well, isn't it like
It's not gonna.
different instances?
Yeah, it's
JavaScript
so it's gonna be
101.
yeah, it's gonna be false. So in JavaScript, the object comparison is the reference comparison. So you can think of it like you and your neighbors have the same red Ferrari. Do you have the same car?
No.
Can you drive this car? Like, no, it's not your car. So.
Yeah, I can.
So can you triple equals it? Will that like make it true?
That would make it even fail fast.
Oh, yeah.
More.
No, never mind.
Right.
Quadruple equal?
More fair. Yeah, what about quadruple?
Yeah. So what are we gonna do? So if we're gonna do a deep comparison, right? We have to do car.
Dot color.
Yeah, car1 dot color equals
Car 2 dot color.
yeah. So car2 dot color.
No, it
That's true, but this is not scalable, right? You can do this for every component. So what are we gonna do? So this is why in JavaScript it's a mutatable state, an object, and that's the paradigm of JavaScript. It's not actually like a functional language where states are immutable. So and we're back to this functional paradigm again because this is what React is trying to bring to the JavaScript community. Is that if you somehow make your data immutable, then this comparison is pretty easy and fast. So yeah, you just check if they are the same thing. So what we want is so this one thing we can do. So we can do say car say if I do car1 dot color. So I want to mutate this to blue. Okay, so car1. Okay. So this and to make your data structure immutable, you actually don't want to just do this mutation right here. What you want is you want to always create a new copy. Okay. So what I should have done is I should do car2 changed is equal to object.assign that we used before. Car2 and let's say color blue. Oops, missing something.
You have one extra
squiggle.
in the very beginning.
Wait, let me.
Right
Oh,
there.
squiggle. So car2 changes like that, where car2 is still the same color red. So this is what we've been doing. We try to use another just a roundabout way to make our stuff, make our state immutable by making a new copy of the state each time we change the state.
Can you do car2 changed equal to car2 and then do it that way?
Car2
Changed equals car2.
equal to car2.
And
then-
car2 changed dot color. Can you assign it like that? No.
Yeah. You mean define a new copy?
The copy, like literally copy that thing.
There's just an extra step because then you have to define what the color is.
But then
Yeah, that's
when
fine.
your car2 changes, your color
No, car2 will change.
change. Yeah,
even
it
if
changes.
it's a
Yeah, so it's
car2
still
change.
linked. Yeah, what you want is one whole
So
entire
you-
copy.
Okay.
Right. So and we talk about that right in Redux. We change the state whenever we dispatch an action. So it's a new state every time. And what does that give us? It gave us the ability to go back to travel in time. Right, because it's immutable. So we can do undo. So there's a history that we can preserve. And this is something really powerful. I mean, I want to detour how powerful this is. Let's just look at this example. I mean,
I'm going to do a quick demo of this. React State Service residence demo.
let me try to stop the recording.